Hello folks, welcome to the second part of the video tutorial in the series of basic electronics for normal people and kids. So yeah, we're going to start off quickly with understanding of a very basic concept of voltage and potential difference, what that is exactly and how that works. So if you please remember from the first tutorial, we have been talking about voltage sources. So these are pretty much analogous to a very normal system that we generally encounter in around us. So just take think of two containers. One is situated at some height and the is situated at below a certain height. So say this container is having full on water and it's flowing downwards. So obviously due to the action of gravity it will flow downwards. And why does it fall downwards? Because there is a difference in heights of these two things, and there is a difference and same thing happens in electrical circuits, and we call them as potential difference, charge difference we call them. Here the difference between the volumes of water, and the water flows down below because of the action of gravity. In terms of circuits, the flow of electrons occurs. The flow of electrons, if you remember, these are called electrons and they're signified by E. And anything which flows creates a current. So current just doesn't mean electric shock or something that flows through the wires. In general, current means anything which flows, a current of electrons. You can even say the river has got current. Doesn't mean that the river has got electric current in it. The river has got the flow, so river currents. And these are called electric currents because they occur due to the flow of electrons. But there is a convention. Current is signified by I, and the convention is that if the electrons flow in this direction, the current flows exactly in the opposite direction. So no need to get confused. Forget about electrons here. We're going to deal only with the current. So yeah, so if you say this is our cell 1, say this is our cell 1 and this is our cell 2, so the current actually flows from this direction. So yeah, so that's essentially it, and it flows because of the potential difference of the whole arrangement. So if you look at a typical circuit presentation, yeah, this is how a simple circuit looks like. These are called circuit diagrams, and these are actually pretty easy to read. No need to be worried about it at all. See this symbol here, it essentially means a push switch. This doesn't necessarily a push switch, but it's a switch. Anything with the break in between wires is a switch. Sometimes they are in closed format like this. Sometimes the wire endings might look like something like this. So then they are push switches. Then there are certain switches like this. So there are different kind of arrangements. Then there are something called DP/DT switches, then SP/DT switches, then push switches. So there are different kind of switches. I have quite a couple of them with me right now. This is called a simple SP/DT switch. It's called SP/DT. SP/DT means single pole double through. Single pole double through. So if say in either condition this and this poles are connected, so now since it's inclined in this direction, so these two poles are connected. So now if this is inclined in that direction, toggled in that direction, this two gets connected. So it's single pull double throw. That's why SP/DT. Similar, my miniature version of this is this switch. It also has I just soldered a piece of wire just to elongate the middle pole, the common pole, and double through switches. This can also be used as normal switches. Say you are connecting this pin and this pin. So when you toggle it in this direction, these two gets connected. When you toggle it in opposite direction, they get disconnected. So you can use them as normal switches. The very familiar version is this one, which you generally see. This is actually a miniature version of what you see in your electric boards in your houses. This is small. This is actually a micro push switch. So when you push it, they do get shorted, sort of gets connected. So this is how a switch is represented in circuits. This is how a resistor is represented in circuits. So this is the symbol of resistor, and what resistor actually does is it actually influences or affects the flow of current. Very similar to this illustration here. We have seen generally in our water supply lines and in our plumbing lines, we see there are regulators to control the flow of water, so which actually affects the intensifies or sort of decreases the flow of water, the pressure and everything. So these are called water taps, sort of like that, supply taps. Similar function is what resistors does. So they looks like these small pieces, and so they actually affects the flow of current. So in this circuit here, in this circuit diagram, I'm using a 220 ohms resistor. I'll explain to you shortly how to read a resistor and how to actually figure out when to use what kind of resistors. So this is a fixed resistor. That means it has got a fixed value of resistance. It cannot change its resistance value. I mean, it is not versatile for controlling different kind of current situations. So it can only allow a fixed amount of current through it all the time. So these are called fixed type of resistors, and this model here, these are essentially carbon bound resistors, because they are made up of some carbon filaments probably in there, I don't know exactly. Yeah, so about reading a resistor before proceeding ahead, I just have a book with me right now. So in any resistor, if you take, you'll see in total of, sometimes 3 bands essentially. So yeah, and actually 4 bands. The last one stands for tolerance, not of much importance though, for basic circuiting skills. So how the color bands actually helps you to find the resistance values. These are the color charts. You can just Google it about resistance color chart. I'm just gonna explain to you how to read a resistance color chart. So the first color of band signifies the first significant digit here. So if it's brown, brown stands for 1. So first significant digit is 1. Then you come to the second band, find the color from and the subsequent number. Here it's black. So black means 0. Second significant digit is 0. 1 0. Now come to the third band. Third band is actually a multiplier, and it's something 10 to the power n. So these numbers are, if say they are n numbers, the multiplier gets first significant digit, second significant digit into 10 to the power n. N stands for specific numbers here. Okay, so here it's orange. Orange means 3, so it will be 10 to the power 3 in our this case. So it subsequently something looks like this. 10 into 10 to the power 3 means what? 10 kilo ohms. So the unit of resistance is ohms. Its symbol is this. Its symbol is this. This is called ohms. Yes, but ohms resistance are very rare to find. Say 5 ohms resistance, they are antique pieces, guys, and these are only available in your school or college labs. They are readily not available in market. Apart from like 100 ohms, it's pretty abundant. You can find it anywhere. Generally the resistance that we use in our project starts from 100 ohms range and goes up to as much as 50 mega ohms. So yeah, kilo means 10 to the power 3, mega means 10 to the power 6, something like that. Multipliers, these are all multipliers, so you need to do some math in here. And the fourth band, this actually stands for tolerance, how much current it can take. Also, one very important thing about resistors, you can actually find out from their sizes. If these are as small as like this one, these are called quarter watt resistors. If they are a bit bigger than this, then they are called half watt resistors. So also, if you don't like calculating your own resistor values looking at the color bands, which I find sometimes time wasting, but it's a very good practice and a very handy solution if you don't have a multimeter with you. So this is actually an illustration of how you could use a multimeter to calculate your resistor values. So don't be afraid of this little testing material. This is called a multimeter. This is a general illustration. My multimeter is in the other room right now, and I really don't want to get up from my seat and bring it and show you to you. But multimeters, actually, the prices of multimeters range from 80 rupees in India to around 40,000 rupees. So depending on your skills and depending on the sort of works you'd be going through, multimeters may vary. So but for the basic needs, I'll just suggest go and grab a very cheap multimeters, because they all function good. There's nothing wrong in those. So when you get a multimeter, get a digital multimeter essentially. It helps you a lot, and there's a central dial, and you'll see here, I'm not quite sure if you are able to see that, but there is a R block here. So this signifies the resistance. So the arrow of the dial, rotate it to R values, and according to the expected resistance values, that what is the range. Say you are having a resistance and you are not sure whether it's 100 ohms or it's 1 kilo ohms. So there are certain ranges in the dial. Fix onto that and keep on checking. Just take two probes and sort of just connect them to the two leads of the resistors. Resistors are not polarized, so you don't have to worry about which lead goes where. The red one essentially is the VCC and the black one is the ground, the common ground. So yeah, that's essentially how you use a multimeter to check a resistor. But always keep a color chart handy if you don't have a multimeter around, which I suggest you should have always. If you are not quite sure, because I'm not dedicating much time here to get a multimeter, know how to use a multimeter, because once you get a multimeter, it becomes pretty easy. Every notations are there on the board itself. You just have to, it's just like using a calculator, guys. So, and even if you are not quite sure, just when you are buying it, ask the shopkeeper about the basic functionalities. He'll tell you. So that's about using that. I almost forgot about other functions of multimeters, about reading voltage from a unknown power source. So these two leads you have here. So this schematic, this illustration actually is measuring voltages from Arduino pins. So you can see it's 5 volts. Arduino gives always 5 volts. We'll talk about Arduino later on. But how to measure a voltage is, again, similar thing. You just rotate the dial to your desired range of voltage, then put this to the positive terminal of your power source and this to the negative terminal, and it will show you the voltage sources around here. This is how you measure a voltage. Now about a current, this may be your circuit. This, just forget about the Arduino here. Say the red wire is going to the positive power source, and this is to the ground of the power source. So you just plug two wires and insert your probes, multimeter probes in there, and again similarly, just assuming your current in the circuit, put the dial in the desired range, or keep on changing that until you get a perfect one, and see the values. So voltages, as I said, 5 volts, and volt is the unit, and it's generally signified as V. In current, it's amps. but 1 amp is too high. 4 amps are something that you get in your switchboards and power cords in your home circuitry, home wiring. It's very, very high current, 4 amps, 5 amps, something like that. Generally for our basic circuiting, our current ranges fall in milliamps range. So milliamps means 10 to the power minus 3 amps. 1 milliamp is equal to 10 to the power minus 3 amps. So yeah, it's that small, and it will be something like 0.001 amp. So yeah, our current range in the basic circuits we'll be making in future will be in milliamps range always. So that's how you measure current, that's how you measure voltage, and that's how you measure resistance with a multimeter. Just go and grab a multimeter if you don't have yet. Okay, so back to our basic circuiting here. This is okay, so we talked about resistors, we talked about switches, batteries I explained in the last tutorial. This is the symbol of an LED, light emitting diode. This is actually a symbol of a diode. This is actually the symbol of a diode, and this with a clover around it and arrows coming out means it's emitting light, so it's light emitting diode. And some diodes you'll see in some circuit schematics, lights arrows getting into the clove, so that means it's light sensitive diode, or it's light dependent diode, or it's light reactive diodes. Okay, so yeah. Also in circuits, if it's written LED, that means it's the color falls in the visual spectrum, and in some cases some LEDs are IR LEDs. If in some circuit schematics they are using some IR LEDs, they'll mention it by the sides. So that's essentially how you read normal circuit schematic, simple circuit schematics. Okay, so okay, so I forgot one more thing about resistors. So you've seen fixed resistors. Now there are something called variable resistors. So they come in various shapes. Yeah, so I had plenty of them. These are called presets. These are called circuit board solderable resistors. They are sometimes called pots for potentiometers, or resistors, all the same. This is a very good quality pot. And okay, so how to read a potentiometer? Generally, when you go to the shopkeeper and ask for a specific value of potentiometer, you can just check it at the back. It's mentioned over here. So it's a 100K potentiometer, means the maximum value of resistance it can offer is 100K, and the minimum is always 0. So this is also a 100K potentiometer. Yeah, and this is 10K, I remember, and this is also 10K, and this is 10K. These are written somewhere in here. Just take a close look with a magnifying glass, you'll find it. But how to check them? Again, to confirm, to ensure that whether their values are perfect or not. So you get your multimeter, poke one of the terminals. As I said, resistors are unbiased, so don't worry about putting the probes, which probes to where. Don't worry about that. Just put any probe anywhere, any of the terminals. So these are the two extreme terminals. If you notice, you have 3 pins here. Yeah, so when you get a multimeter, just put one of your probes here and another probe here, and try to read the resistor by changing the dials of within the expected range, and this will give you the maximum value of the resistance a potentiometer can offer. So that's how to check maximum value of a potentiometer, and that's how the potentiometers are actually named or asked for from shopkeepers. Say, give me a 100K pot, give me a 10K pot, something like that, you know. And the middle lag here is actually used if we are intending to use a potentiometer in a circuit where we need variable resistance, resistance that need to be changed often during different parameters, different conditions. So a variable resistance is often illustrated in circuit diagrams like this. So this is your resistance, normal fixed resistance, and this is the middle leg of your resistance. So I almost forgot explaining one more thing here about resistors, is that resistance, the amount of resistance a resistor offers is directly proportional to the length of the material of resistor and is inversely proportional to area of the material which will offer the resistance. Yeah. So that's a basic function. So if you see here, they tried to actually illustrate it, the same concept this here. So as you move around your pointer here, again you rotate the you essentially, yeah, so you hold it and you rotate it. This is not getting hold on to me. Okay, so you essentially use and rotate it. So at a point it will give you 0 resistance, and at extreme other point where it's stuck, it will give you maximum resistance it can offer, and in between it will vary according to the pointers here. So this is how a potentiometer is drawn in circuit diagrams. So whenever you need a middle, so generally we use only 2 pins of a potentiometer, the middle pin and either of the pins will work. So this middle pin will go, as I said, unbiased, so don't worry about putting them anywhere in the circuit. There is no plus, no minus for resistors. So now when I actually put these 2 pins here and I extend them and I rotate, the resistance between these 2 pins changes. Exactly. So that is about resistors. Also, the relation with current and voltage or something like this. There is a law called Ohm's law. Mr. Ohm, who founded actually the resistor concepts, and in his and actually the unit of resistor has been awarded by his name, ohms. So V, which is voltage, is directly proportional to current, the concept says, which means voltage is directly proportional to the amount of current supplied or applied. And if we equate it, so there is a factor which gets multiplied to it, and that's called resistor. So resistor is V by I cross multiplication. So in a circuit, say like this, if you know how much current is needed for an LED at maximum, or how much current this battery can provide, and you know the voltage of the battery also, so you can easily calculate how much resistance you need for the circuit, because according to this equation here, the resistance, for finding a resistance of a perfect circuit, you need just voltage and current. So that's how you actually use this concept to find resistor values for specific circuits. Just as a thumb rule, 220 ohms resistors are always used in serial with LEDs, and sometimes if the voltage rises from 3 volts to say 9 volts, we'll use a 1 kilo ohms resistor in series with the LED. So in series means anything which is in line. So this diode is in series with this diode, this resistor is in series with this diode. So this is called in series circuiting. Something called parallel means everything will be in parallel. So these 2 resistors are parallel, these 2 resistors are in series, R1, R2. So the equivalent resistors of this whole length is R1 plus R2 for series. For parallel, it's not the same. The equation is, say this is R1, this is R2, these are 2 different resistances, and the equivalent resistance of this loop is found out by this equation, 1 by R1 plus 1 by R2. So that's as simple as that. Yeah. And voltage always remains constant in parallel forms and changes at different points in series. So always mind that. These are very basic concepts, and these are essentially taught in electronics classes in high schools or engineering, but there are a few thumb rules that you always need to remember. You may or may not use them sometimes, but yeah, that's essential. Okay, so we have made here the schematics, basic schematics physical version on this board. You can see we have a coin cell as a power source, and the wires goes to the power lines. The positive wires goes to the red line, and the black wire, this is the ground, goes to the blue line here representing negative. I'm using jumper wires to draw this power from these two lines to the main portion of the breadboard. So jumper wires are something like this. This is called a male to male jumper because they have got pins at both of their terminals. This is called a female to female jumper, as they have got no pins but they have got holes in them. I don't know why they're actually called male to male and female to female. You better tell me. So this is again a hybrid. This is male to female. At one end they have got pins and the other they have got holes, so they can go into each other looping around. Or you can actually do something like this, put the male to the female and extend the wires, or put the male in here at the board, poke it up, something like that. And don't worry if you don't have jumper wires. There are some other things called cool stuffs called this. These are called male and female headers. So you can just cut as required numbers and solder them to the ends of the wires and make them your headers. So this circuit is pretty much simple. I'm just drawing the positive wire, putting it to a resistor here, 220 ohms. The resistor goes in serial with the switch. Other terminal of the switch goes to the positive end of the LED. Yeah, you remember how to read LED, right, from the last tutorial. And the negative end goes all the way through the jumpers into the breadboard to the negative terminal of the battery. So now when you press the switch, it glows. Yeah, so I know it's not very much interesting or something rocket science or something like that, but yeah, it's fun to see your first circuit from scratch working, ain't it? Thanks for watching. Goodbye, till next time.